For this next nomenclature video, we're going to be speaking about oxides, hydroxides, and hydrides. And these chemical types are classified basically by the type of anion they're adding to the mix. So the cation is just like in the video of haloid salts, which I urge you to watch so that you can understand the naming style. The cation is always going to be a metal. And remember, we have metals that only have one valence, or we have metals that have two or more valences, okay? So in this case, the cation is always going to be metallic. That's how we recognize these. And the anion, depending on the family, is going to be oxygen, which is invariably -2 in its charge. We're going to have hydroxide, which is invariably -1 in its charge. And we have hydrogen, which is always going to be -1 in its charge when it's acting as an anion, right? So when we write the chemical symbols, we're going to get O -2, OH, that may need parentheses sometimes, depending on what you're combining with, and finally hydrogen, which is always -1. And remember, metals with one valence, notable exceptions from the transition metals are silver and zinc with +2 and +1, aluminum, which is a representative metal, so that's not really an exception, but our typical ones, which is sodium, magnesium, +2, calcium, what else? Potassium. And with multiple valences, the usual suspects: copper +1, +2, iron +2, +3, lead +2, +4. And remember, these charges and everything, I'm not making it up. You can find it in a periodic table, or you can find it in an oxidation chart, so that you can make the different combinations. Now, once again, if I have a metal and an oxygen anion, I'm going to form an oxide. If I have a metal as a cation and a hydroxide as the anion, I'm going to get a hydroxide. And if I have a metal and a hydrogen atom as an anion, I'm going to get a hydride. Naming style is going to be exactly the same. So I'm going to separate it for you a little bit right here with different colors. If we only have metals with one valence, the naming style is very simple. We just say name of the metal, and depending on the type of cation plus the word oxide, and I put it between quotation marks because it's literally, you have to write oxide. Depending on the cation, it's going to be hydroxide, or if the cation is, if the anion is hydrogen, we're going to get the word hydride. Okay, so that's for metals with one valence. Concrete examples of this. Let's do a little mixture, and let's do some with sodium. Sodium is Na+. And as I remember telling you, oxygen is -2, OH is -1, and hydrogen is -1. So once we combine all of these, what are we going to get? We're going to get Na2O1. We don't do the 1, so we just write Na2O. Then we get Na +1 OH-. When we do the crisscross, we get 1s, so we don't even write them, NaOH. And last but not least, sodium +1, hydrogen -1. When we do the crisscross, what are we going to get? Sodium hydride. And again, what is the name of our metal? Only one valence, so name of metal plus the word. Sodium oxide. For this one, the anion is hydroxide, so we get sodium hydroxide. And last but not least, sodium. And since my anion is hydrogen, the word is hydride. Okay? So again, this is for metals with only one valence, such as the case of sodium. Once again, and if not, again, I invite you to watch the haloid salt video, which goes very deep into this topic again. We're just changing the name of the anion. When we have metals with two or more valences, we add something additional, because remember, we have two types of names. So for the modern name, or the stock system, modern or stock name, we're going to use the formula for the nomenclature is going to be metal name, Roman numeral, which indicates the valence of the metal, plus the word oxide if we combine it with oxygen, plus the word hydroxide if we combine it with a hydroxide ion, or with the word hydride if the anion was hydrogen. So this is for modern or stock name system. And when we speak about classic nomenclature, I'm going to try to write faster. We use the metal name, the Latin metal name, with ic ending. This is two options, ic ending or us ending. This one for the lower valence, and this one for the higher valence. And then after we add this, we don't need a Roman numeral, and we add the word oxide, hydroxide, or hydride in its ultimate form if we use hydrogen as the anion. Let's do some specific examples of this. Again, we have something such as copper. Copper can be +1, copper can be +2, and then we mix it with all these different types of anions that we have here, OH or hydrogen, and we're going to get different formulas. How many different compounds? We can get 6 compounds from this mixture. So the first compound that we get is 1 and 2, Cu2O, and if we do 2 and 2, CuO. We can also do CuOH, or here when we do the interchange, CuOH in parentheses 2, and finally CuH or CuH2. Both of these compounds again have the same naming style, but we use the valence for the different to separate which is which. So for example, this guy up here is going to be copper, which is my metal name. Since we used the 1 valence, the Roman numeral has to be Roman numeral 1. And since it's with oxygen, we use the word oxide. This compound, which we also use copper 1, is going to be copper hydroxide. And last but not least, copper 1 hydride. The ones on the bottom where we use the +2 valence are going to be same thing. Copper is the metal name, Roman numeral 2 for the valence, oxide when we combine it with oxygen, hydroxide when we combine it with hydroxide, or hydride when we combine it with hydrogen. And that's for the modern name. In this case, again, copper has 2 valences, +1 and +2, the lower valence and the higher valence. So in this case, these compounds can also be named using their classic nomenclature, but we're going to substitute copper 1 for the word cupras, because copper in Latin is cuprum. So we substitute the us ending, and this becomes cupras. And copper 2 is going to become cupric because it's a higher valence. So we get, instead of saying copper 1, we say copper oxide, copper 1 oxide. We are going to say cuprous oxide or cupric oxide. This is especially helpful in the lab because many compounds still use this old style nomenclature. And then again, copper 1 is substituted by cuprous, so copper 1 oxide, cuprous oxide, cupric oxide, or we get cuprous hydroxide when we combine it with hydroxide, or cuprous hydride, or in its defect, cupric hydroxide, which is this one, cupric hydride, which is that last one. And that's basically the naming style for these families. All you have to do is identify what we're talking about. If we're dealing with oxygen, it's going to be oxides. If you're dealing with hydroxide as the anion, we're talking about hydroxides. And if we're dealing with hydrogen, we're talking about hydrides.